Hello everyone, welcome to Try Right, the new era of learning. This is Pack 365 in Module 2, Part B. Today we are learning about AO-star algorithm in artificial intelligence. In previous section, we discussed about AO-star algorithm. So, in this section, we will learn about the example. Okay, the AO-star algorithm is based on and on OR graph to be break complex problems into the smaller ones and solve them. And the end side of the graph represents those tasks that need to be done with each other to reach the goal, while the OR side stands alone for the single task. So we all know the definition. So here it comes to the AO star, like and or star, like we can say that algorithm is a graph-based search algorithm used to problems where the solutions can be represented using and or trees or graphs, typically in the areas like problems, decomposition, planning, and expert system in artificial intelligence. So, how the AO star algorithm works? Like we can say that we use AO star. So, it is a standard algorithm like A star works as for simple pathfinding. So, AO star is required when some sub goals must be solved together and other or optional or right we can say that and for both conditional based and or for optionals. So it is used with the problems like or nodes and end nodes, right? So it's working here like it starts at the root node, the root representation, the main problem, expand the node, generate leads children's, and children can be or node or end node, okay, sub goal or solved goal, all the goals. So it has evaluated cost also like F equal to J plus and sorry G plus N. So G equal to cost of fare and H equal to heuristic estimated. And it use update the graph while you're traveling with RN conditions and choose the next path. AO star flows the least cost path through the end or graph. Uses backtracking if needed to explore better plans and then better paths. Repeat until the problem is it cannot find a solution. Okay. So Eostar update cost backward from the leaf to the root. Dynamically, the programming feature helps to avoid the recomputing and handling the graph loops. So let's see the one example from. So we all know that having a child, which has a conditional. Here we can say we have optional having child or adopt a child. It has parent and child has an or optional, and in the second part we can see having a child, getting married, giving birth to baby. So here I have it both condition based. Right? We want to get the married and baby. So it is a condition based subgraph subnodes. So like this, it is also same to here. So we want to buy the car or steal the car. So we have optional to travel this or we have conditional basic to we have satisfied with both conditions. So we have example problem like AO star with the A and or graphs. Okay. So here we can see in this example we will demonstrate how the AO algorithm works using and or graph. Each node in the graph is assigned to heuristic value denoted as h of n, and the edges length is considered as 1. So like it starts from like this is a simple example graph if you want to represent it. So cost optimization is in and or graph using AO algorithm for pathfinding. This example demonstrates the applications of AO a star and an or algorithm to optimize the pathfinding in a problem which complex dependency. The algorithm explores path defined by and or conditions, calculating the least cost solution by the dynamically updating the node's cost. And condition requires all the connected nodes to be considered while the or conditional allows to selecting the least expensive optional, right? So here we can say we want to print this output by taking some set of graph. So like we're representing this graph and we want to find the and or nodes. So update cost is or like that we must find the what node in between the end and which node is optional and which node is conditional based. So we find the shortest path for it. So we want to print the output like this. We want to print this output. So which is conditional based and which is output end based here. We want to find the path like this. So let's move into the VS code. So we can execute this code. So here I creating AO star dot py. I created it. Okay, I see. Okay, wait. Is AO star dot py. Yeah, fine. So from here we want to create a first we want to create a conditional, right? So here cost of we take h as condition and weight equal to one, and we want to mention a condition based like if and or, like we take a condition as if and, to take condition in and to take condition in or, if and in condition, if or in condition, like that. So here we want to first update the condition. So take has def cost h condition weight equal to 1. Okay. So I take a cost as a empty dictionary. So I want to consider it. Okay. So let us here given condition here. So here we can take A and D and if and in. We want to check the condition first, is existed or not. And condition. So we take a variable here, all the nodes of and condition to arrange in the condition of and. Okay. Now for the path A equal to and we want to use join here, join function to from who joining which, and we using to join and nodes. Okay. So again we create another variable like this is some, this is also path here, but we do just create a path here. That's it. So here we can take sum. Here we want to do the sum of h plus h for h and nodes. Node. Wait a second, we didn't create here node, right? And nodes equal to condition and okay, right? So h. Okay, we take condition here and we want to place it with VIGST weight. That's it. We're doing sum for node and weight, cost and end if we get conditions and nodes equal to and join and nodes. Okay. Okay. For weight, for now we want to arrange for node in and nodes, right? So this wait a second, this is one waited, okay, join. So wait, we are not at it dot join. Yeah, it's fine now. So now we take again cost. For cost, we are considering again this path A equal to normal path A. So we base condition here completed. So same like the same we are considered to R. Okay, same we are considered to R here. Same this for or in condition. Same we take R nodes equal to condition. R nodes in condition, and same for your path B. We want to create a path B equal to R dot join. Same again. Here we create one R nodes, and we want to create again normal simple path B. This is equal to min here. We are doing minimum average, right? So min of for H, and hold the node and plus wait for node in OR node. So okay, we'll terminate it. So again, we just take your cost of path B equal to path B. Okay, so we want to return it. Return the cost. Okay, I want to return the cost. Done. Now here we want to take update here. So here what we are doing here, we're updating, right? Updating the cost. So we take def update, the function def update cost. Yes, same. We want to update the function there for what we updating. So here we want to update the conditions and main nodes of the list. And for key, we create a key. We take a key. For the key, we want to print the. We take the minimum values of the conditions. So for this main node, we want to consider a list of main node also. So you take H conditions, H conditions, weight equal to 1. So we take a variable called main node, so taking list conditional dot, we are assigning keys here. We use keys function, and for the main node dot, we are using reverse function to reverse the node, and list cost for key in main node. Okay, so we can take conditions equal to conditions of those keys. So conditions, and we want to print that key again, right? So we will use the print statement, and then we could print the key, comma, in mark. Here we're printing the condition. What conditions? Conditions of key, comma. Again, we're printing the statement here. Okay. So its final output will be printed. So we like that we want to print it. So for I want to take cost. Again, I take H. Again, I take conditions and wait. Just wait a second. Fine. So let's taking cost, and here we are again taking C equal to cost of H, and then again condition, and then again we take the weight as usual. Then we consider H again, taking keys and minimizing it. We calculate the maximum of average of C and values. And taking the cost of the values. So here, okay, here capital C. Okay, now it's fine. Let me take the cost, least cost key equal to again cost of H. So we take again condition and weight again, and we're returning the least cost here. Yeah, it's okay. Now we complete the first part of the code. So now we can consider here second path. So now we consider. So we want to print. Now we want to print the path here. So for printing path, we want to consider take first. We want to create a shortest path for it. Okay, for printing path, we want to create a shortest path for it. Okay. So we are returning the value. Then again, we are taking the print the shortest path. Right. So we can take def, take a function called shortest path, and take start. Take updated updated cost, and we want to consider H. Okay, H we can consider here. So now let's take to define. So okay, now we want to start from path. We are considering the path equal to our path is start. Okay, we condition if start in update, if start in update cost dot key. So what we I want to minimize the cost, average of the cost. Take a variable of average of the cost, and min update. So what my update goes to? So my update cost starts from value. Update cost start. I want a dot value. So equal to my key is equal to list of update cost. Same here, we want to again start it. Start equal to keys, my keys, right? So start equal to keys here. So for keys, I want to assign values again. So keys for keys and min cost equal to min update cost, right? So I start with dot values. For keys, I am assigning the list update dot cost. So it's a little bit confusing sometimes. So keep it do carefully while you are doing it. Okay. We want to assign the keys for keys. So keys dot. So now we take values again. In values list equal to again update it. Now each step we are considering line by line here. So again in it we take start. Again now we want to assign dot values. Now finally we consider index here. Values dot index min cost. Okay, now we find some we create a path. So we want to find path. Now we want to create the find path, right? Now we want to create the find path here. So we created the variable here. Okay, fine. Now we want to create the find the path here. Find the minimum path. So we want to take next equal to take a variable as next and we entering the keys in it. So we take the index. We are splitting the index by using split function. And next we are adding the next path for add to path for or path. So you're assigning the path for end and or. First we take the end. If length of next equal to one, right? Equal to one. Then it start from then it start equal to next. Right. Okay. So I take again path. For path I'm taking plus or equal to and let's say to what the shortest path start update cost fh. So here we want to consider again and now we want to add to path for and now end path. So if it's not we consider else. So for else it is not or first check the or and if it's not considered in or so we want to moving the path to the direct and conditional for to the conditional base. So for path we are assigning directly. So for path we are assigning directly plus equal to like we are printing like this. Printing index So if we're printing the index, right? Now we're taking start equal to next row 0, path equal to what is the path? Start here, update the cost and plus h, and for here we want to do the plus. Okay, right. So here we can do it. So here we can do that like plus, use plus operator here like as a function, and again we want to consider here down, use up to down. Second we are taking here start, so we are backtracking here for next to minus 1, taking next to minus 1, and here we're taking the path. So we are taking h, and here we want considering a place. It's fine. It will be okay updated. So update cost, not updated cost it. So path equal to update the cost. Yeah, it's fine. No? So directly we are returning the value. So returning the path. Okay, so here we done. We're adding the path and we create the path and we assign the path to those. Okay. So for now for final. So for now we are creating a final path here, right? So we consider here final code for visualization. Final code with for using a graph. It is for graph part. So wait a second. Until that, we can say that it is a one of the active code. So due to lagging of time, the next code will present in next section. Okay. So I hope you see there. Thank you.